Welcome DKP Sogong aboard. Your learning journey starts now. Ever wondered why the Riemann hypothesis is such a beast? It's been haunting mathematicians for over a century. The classic question is simple. Are all the interesting zeros of the zeta function lined up perfectly on the real part equals 1/2 line in the complex plane? Most folks try to hunt these zeros down numerically. But what if we could prove it without counting sheep? This approach flips the script, moving from number crunching to understanding the very meaning of these zeros through something called semantic closure. Think of it as finding the true essence, not just the shadow. So, where do we look? Not just in the formal space of equations and symbols like zeta of s or c of s. That's like looking at a map instead of the territory. We dive into semantic space. What does that mean? It means we care about how things are generated. Think prime numbers as fundamental building blocks. It's about provenance, who's related to whom. And crucially, closure, when can everything neatly tie up? A zero here isn't just a point where the function hits zero. It's a state where all underlying obligations have been satisfied, a base zero normal form. The key insight: the real part sigma tells you about the generative order, while the imaginary part t is just phase. If the orders don't match, you can't get true closure. Now let's talk poles. Imagine two entities, a direct pole P of s and its dual counterpart P of 1 minus conjugate s. These aren't just random points. They're tied together by their shared origin, their common provenance. They interact within a provenance-complete bipolar closure. For them to achieve a stable base zero state, their generative strengths, their orders, must be perfectly balanced. If one is stronger, it leaves behind an unresolved obligation, gamma, that the weaker one can't handle. It's like trying to balance scales with weights of different magnitudes. The only way for both sides to fully settle, to reach base zero normal form, is if their orders are equal. And mathematically, this equality condition forces their location onto the critical line, Re of s equals 1/2. That's the fixed locus. What exactly is this base zero normal form? It's more than just s equals 0. Numerically, that equation might hold anywhere, but semantically, it means something profound. Every non-base generative obligation has been mutually eliminated. All relations are resolved, no maximal unresolved relation remains, and importantly, nothing at the same level regenerates. It's a terminal state. The proof hinges on showing that if you have such a state, the generative orders of our two poles, P plus of s and P minus of 1 minus conjugate s, must be identical. When you translate this order equality back into the classical coordinates, using the involutions j of s equals 1 minus conjugate s, you get sigma equals 1 minus sigma, which means sigma equals 1/2. Boom! The critical line emerges not from searching, but from the structure of closure itself. So why is this different? Crucially, this proof doesn't lean on traditional crutches like numerical checks, zero density estimates, or random matrix analogies. It doesn't assume any offline zeros. Instead, it treats potential infinity like all primes as open reinstantiation of finite templates. The beauty is in the architecture, a machine-auditable certificate system, checking things like prime provenance and pole balance ensures rigor. The core theorem holds within this defined semantic system. The bridge to the classical statement, the fidelity compilation, is specified, but external validation is a separate step. The internal logic stands tall.